today's first session, I'll be talking about 5 things every architect should know. Why I chose this one and why I chose this for the first topic is because let's start with why and what should we know first, and then we have a couple of other sessions happening on big data. Let's go let's take a deep dive onto the other architectural stuff. First, let's see why and what the architect should know. I'll start with the first one. Who is your actual customer? Let's say what happens is our customer approaches you and you are the architect and will speak to them. What is the first thing you should be thinking about when you're talking to your customer? The customer gives you the requirement. Who is actually going to use the system? If you look at it, actually the customer is not the customer who is going to use the system. It is actually the one whom you are building the products to. So, if I come to this code, your customer is not your customer. The customer whom you are actually speaking to, you are getting the requirements from, and you are going to talk the solution to, is actually not the customer who is going to be using the system. So, your customer is not your customer. The actual customer is the end user. So, first thing is, in any, whenever you get the task of designing some system, the first thing that happens is that you go to the requirements casting. That is the key meeting that happens, and there it is very important for you to think in the perspective of the end user. It might happen, the customer says that I need these functionalities. Fine. You will be a listener. You will not think about the implementations at that point of time. Just listen. What is the actual requirement? But then, don't implement it. Just think about the functionalities required. And you should also keep in mind with all other stuff what a good product should have. There are a lot of products in the market which are successful, but there are a lot of problems with that. Sometimes a product is really good when it comes to the development, or when some people are doing the maintenance and some people are doing the support thing, they feel it is really difficult to work on the product. Why is that? It is successful in the market, but it is so difficult to work on the product. So I actually don't term it as a good product. I call it a good product only when it is successful in the market, but also it should be easily maintainable. If I give it to a programmer, if a new programmer comes in and if he is looking at my architecture and my product, he should be easily understand what it is. And if there is a support staff working on that particular product, I want the support staff to look at it as, okay, I can actually work on this. I can take calls on this. So that is what I am talking about. So that's what it is. Whenever you are giving a solution, so you got to think in the way of the actual customer. What actually he wants to use in your system. Okay, so let me give an example. There is a customer who comes and asks you, you are the architect, and he gives you, I want these features in my application. Now, say that is a website that is to be created. Now, he will not say anything about the other functionality, other things like if the website has to be available all the time, like if it is an intern or external, or if it is like mainly the performance, how many users are going to use my application. It is your responsibility to ask. You ask the customer. He says, okay, right now it is not important for me. What will be your reaction to that? Anyone?
What do you mean by right now?
Huh?
What do you mean by right now?
Yeah, good question. Okay, right now means, okay, you build the system first, let me see how many users use it, then I'll tell you whether you got a good performance system or not. So what is your reaction?
You'll be lining up a lot of rework, provide it that will be better to plan.
We do a better planning. So as an architect, yes, it is your responsibility to tell, though it is not a functional requirement. I know that this is not a functionality to use in our application, but yet it gives a feel. It gives a feel of the application. The customer and the end user who is using the application should feel like using the application. That is the most important thing. So this has to come from the architect, and he has to make sure that he conforms to all this.
So, but going by that point, right?
Yeah.
So, let's say the customer says that I don't know, maybe you're supposed to design for 1,000 users for next 5 years, but right now only 50 users can use it.
Yes.
So the user will not feel the difference anyways.
Yes.
So whether you design it the best performance or performance not that good, it will make a difference right now because you're just designing for a small number of users.
Yes. Okay.
So what about the context? What about time to market? I mean, is that not important? Because you can always go and come back.
Yeah.
So you design for this, but you don't have to. Time to market is important.
Yeah.
You don't have to go out of your way to do performance tuning right now.
Yeah.
Because it's a trade-off.
Yes, it's a trade-off. Yes. The question, the architect, what he should be asking is, as he already asked, what is the user base? Yeah. The guy said, like there are thousands of users, but still the point is he is not considering the proposal given from the architect that we have to do a performance test. The context is like architect made his point, but the customer is not willing to take that point. There could be several reasons behind it. Like customer is running behind or he is not having a budget to allocate. Of course, you all know that performance tools are required for doing performance testing and all that. So it is really difficult for customer, if in case it is a customer who is running tight on budget, to allocate a budget for this performance testing tools. Of course, he will say that, but it is at the end of the day, it is the product that matters. It is the product that matters. How good is your product? That is what matters. So you have to do your job. You got to push. You got to make sure that application, the product is good at the end of the day. Yeah. Okay. So going by one of the quotes by Iterative, which is a CTO of Choice Hotels. What he says is, if the customer, that means the guy who came to you asking that I want this product, if he is not caring about his customers, then don't do the product. That is very strict way of saying it, but you got to think in a way that yes, actually what matters is the end product, what I am giving to the customers. That is what matters. If you are good, you got to make a good product. That is what matters at the end. Yeah. Okay. And the next point what I have is, you are not a problem solver. What do you mean by problem here? Problem is, customer came to you, this is my problem, solve it. You as an architect, yes, of course, you know everything. You give a solution to the problem. What happens? You gave a solution, but at the end, is it a good solution? What should make it is a good product. So along with the features, what is asked, it's your responsibility to make the system without even asking from the customer, these things are met. My application has to conform to these stuff. Security, performance, all this stuff comes into picture. So it's my responsibility. If not asked by the customer, it's my responsibility to give all that. So finally, the say is that you should have a vision of a good product. Of course, the features are important, but have a good vision for a good end product. That's what matters the most for any application. So that's what a key takeaway from this. Understand the needs of actual customer. Of course, the customer what says, maybe there is a difference between wants and needs. The customer wants what his customer like. These are the things I think that the customer wants, but it may not be that it's needed. So actually what is needed by your customers might be different. So you also have to think about it. So it is what the product you made will be used by the end users. Any questions on this? I'll move on to the next.
What do you do with a good product?
Sorry?
What do you do with a good product? Whenever you design a product,
Yeah.
can you make sure it's a good product?
Yeah, when you start off with that, I really can't say that. Yeah, what I'm saying is at the time of delivery, I should have a vision that my product will not compromise on this stuff.
There is
We talked about when it's to the mainframe at that time, right?
Sorry?
When it to the mainframe systems,
Yeah.
whatever they wrote, that will be nice. And it will be like...
When the right first.
Yeah. now we came to the cloud era, right?
Yeah.
Now it will take what are the system you will say it's not good.
Oh, okay. 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 What I'm saying is, yes, When I started off, it was good. It is a change of, what do I call it? It is a change of technology. Okay. The things change.
Same thing. There is a old wine in new bottle. That's it.
So he is saying like when you should play good product, you cannot make sure every time you product.
No, what I'm saying
Serving
is,
the needs of the people.
when you start off, you should have a vision of making sure that the product what you develop is a good one. Like, you can't compromise at the start itself. Okay, the customer said he needs this. Okay, let me do it. And whatever the ethics what I have is okay. I'll make sure that the product makes sure that it confirms all this stuff. I'll leave out. I should not be happy.
I think the point he's making is using the word good product
Yeah.
instead of that meets or exceeds the expectations or the considerations.
Yes.
See, if you go back 30 years back when mainframes were designed,
Yes.
there was no web technology as a consideration.
At all.
Yes. Now the considerations have changed it, whether it is web or a cloud or something.
Yes,
Of course.
decisions were made actually. Whatever connecting we have implemented, earlier itself it was made in 40-45 years back.
So many dimensions, so the competition is
Like virtualization was existing where now we are using it in new form.
See, the simple definition of quality is conformance to requirements.
Yes.
Okay, state and sweet and state.
Yes.
So if you are meeting the quality, your product is good.
Yes.
If the requirement changes, you are using and negotiate the requirement with customers.
Yes.
And that's the role of architect.
Yes.
Very true. I'll move on to the next one. Okay. Learn a new language. Am I talking about any new technical language here?
Not just
Okay.
business language or
Exactly. That's what I'm talking about. Okay. What is required for an architect is, don't take it literally, that's the point, the term I coined, business domain knowledge. Take it as a business language. What is business language? When some customer approaches me, I have to listen to his requirement. When I'm listening to his requirement, consider he is totally a non-technical guy. He is talking all sorts of business terminologies which I am totally not aware of. What happens? I am totally blank. I can't seriously understand what he is talking about. I go back, see, okay, Google for the terminologies and try to understand what this guy is talking about, then come up with a solution. Is it a good approach? What needs to be done? Like, when you know that you got to work on this product, you should know the business language. As I said, the requirement gathering meeting is a key meeting, like when you will be discussing about the requirements. So that is when you will get to know most of the application that you are going to work on. So you need to understand what the other person, the customer, is talking about. If it's a banking domain, you should know all the banking terminology. May not be everything, at least the basic business. At least you should be able to understand what the other person is talking about. That's what you are saying here. What the industry says is it is highly desirable for an architect to have an understanding of the business. It doesn't say that it is like mandatory, but it is highly desirable. Because without it, it's really difficult for you to manage. It is really difficult for you to talk to your customers. That is what is going to be difficult for you. So you should know what the other person is talking about. And why it helps. Often the business domains are associated with particular architectural patterns. So if we see in some domains, like some domains will be going in a particular architectural pattern. So when you are knowing, when you are talking to a customer, when he is saying that I would be needing my product in this domain, so you know that which architectural pattern you use already in your mind. You are not going implementation specific, but you know that he is talking about this domain, so I have to think in these terms. So that is the key thing. So that is what helps. So at least try to know a basic business of what the customer requires. It should start even before you start working on the product itself. Any doubts on this? Questions? Okay. So just the key takeaway, understand the business domain before you start off. I'll move to the next. Okay. Perfect versus good enough. What am I talking here?
time versus money.
One, any other guesses?
Time to market.
Time to market?
Quality.
Quality. Quality. Okay, nice, good. I heard some trade-off. Trade-off? Okay. I'll come to that. Okay, what here I'm talking about is, first question, are we creating problem by seeking the perfect solution? What happens usually is, I am an architect. What I do is, whenever I get something to design or I take a task of architecting something, I tend to think to give the best, perfect solution for the product, for the requirement. Okay, what happens with that? What I tend to do is, I think too much. I go like each component what I have to work on. So I go a lot deeper into that. And what might happen because of this is I come up with a huge architectural diagram and then it leads to over designing it from this design. So that is the perfect solution. Of course, who doesn't want a perfect solution? Everybody wants a perfect solution. But I will come to that later stage what actually is upfront design and incremental design. But here what I am talking about is that when you get something to design, not only at the initial state of the product, even during when you are doing the software development, in between whenever you are taking some decisions, do not look for the perfect solution for that requirement. There is another term, so what is good enough? What is good enough? And when you know that it is good enough. What is good enough? It doesn't mean the solution isn't right. So what does it say? I will have to stick to good enough. That means that is the solution not right? It doesn't mean that. Actually, this statement gives a clear explanation of what is good enough. It means the imperfections in it does not impact the system's functionality, maintainability, performance in any meaningful way. You can add on other stuff also according to your product development in this list. That means that whenever you are saying that you are going to have a good enough solution for the correct requirement, I will not be compromising on this stuff, yet I will have a good solution in my hand. That's what we are talking about. So, do not look for the perfect solution in your for the requirement that you have got in your hand. Look for a good enough solution and move on. That's what the key takeaway from this. Any questions?
So how do you gauge performance? Performance is very subjective. So you can say 90% performance. How do you gauge it? Let's say, when do you say it's meaningful?
In terms of good enough solutions. Okay. Let's say,
Sorry, rephrasing the question.
Right.
So, where do you stop? Let's say this is where performance stops.
Yeah.
Okay. Say performance can be like 100% performance. There is no perfection for it. So how do you gauge this is where it is stop?
okay.
Is there any tool or something which you use?
There are a lot of things available in our market to give software performance. But what I'm trying to say here is that you will have some statistics that I need to have this type of performance, beyond which it is not available or the other way around. So what I look for is, this is the performance I'm looking at. You could still make better. That means you can look for 100% like super fast application, but I'm not looking at that. If it conforms to say this is the percentage what I'm looking at, that is good. That's what I'm looking for. It doesn't apply to only performance, maintainability, functionality. That's why I said. So look for good enough in every aspect. So if you want to give any statistics to each of these, go on, give it, and look for those numbers. So if that is enough, yeah, sure.
Yeah, I can relate to his question. He's saying that performance can never be enough. So as a programmer,
Yes,
I can
yes.
keep optimizing, but that's exactly the point. That
Many times we will have there might be some requirements, maybe industry standards are there which will tell you, this performance is good enough.
Yes.
In some taken point.
Right.
You don't have to be See, suppose I am visiting a website for a very simple example. So it can load in 10 seconds, it can load in 5 seconds, it can load within 30 microseconds and 40 microseconds. Does it really matter if it is 30 or 40 microseconds? No.
Yeah.
So
And
there
that's
you
where
have
the
to stop.
programmers, that's what the programmers fret about. That
Yes.
I will get that 1 millisecond also.
Yes.
And
Yes.
I will keep trying.
That is
And
what I was
That's
talking
yeah.
Yes.
Because I want to make it as fast as possible. And it's also challenging to do those kind of things. That
Yes.
okay, from 5 seconds I made it to 4.95 seconds. And
Yeah, you might feel like, oh, you achieved it so much. You might even showcase it in front of your customers or even from fellow colleagues. They might feel happy about it. But
most of the time that also leads to kind of complex.
yes,
complex.
it might lead to a complex. And somebody else who is working on it might not know what you have done.
Might have gone for non-standard solution.
Yeah, might have gone for a non-standard solution. Yes.
How about securing the application like that hacking level?
Yeah. Yes, we all know that it is.
How do you make sure that?
Yes. Yeah, we all know that we can't compromise on the security. That is for sure. But of course, you can have some security guidelines or things that you have to take care of before releasing a product. So there could be 100 in the checklist or there could be 50 in the checklist. The 50, what I'm saying, which need not be in the checklist is like really is required. The first 50 is really required and the next 50 need not be, may not be as of now. It can happen over the time.
As an architect, you should ensure that all the guidelines or whatever
Yeah, what I-
standard things should be met.
Right.
But despite the certain loopholes which should be there, and how to combine those things.
Yeah.
As an architect, how do you support it?
Yeah, what I'm saying is, yeah, our software is never, what do you say, it's like I really can't say that my software is not hackable. It is always possible. But what do you look for? Like, I will make sure that at least these things are taken care of as the security checks before releasing it to the market. So, I can choose to go ahead and make some more extra care to make my application secure. But make sure that this is done.
You also again talk about secure enough system.
It should be secure enough. So
Secure enough for
Oh yeah, in this case I can really change good to secure. Yeah. Yeah, seriously. Good enough, secure enough.
So I have a question here.
Yeah,
So somehow I'm not sold on the idea of actually maintainability.
Okay.
Just a basic example. So we had the system which used to basically get into this speed problem
Okay.
that false speed has been sent into the system.
Okay.
And a lot of tickets would go around, fly around, something would happen, something would go wrong.
Okay.
So I kind of started automating a lot of it. It is a very complex solution. It is, very difficult to explain it to people how it works.
Okay.
But the whole concept here is that it will basically detect that there is an issue. It will log it, send the emails that you need to fix this. Once that is fixed, it automatically pulls, corrects it. It's completely, basically zero tickets are logged for that. Now that's kind of what you're trying to aim for. You're trying to go for perfect. I don't want this kind of thing. And that requires a lot of understanding of the system. So sometimes you need to design a complex solution because you have to understand what the client's pain point is. His pain point was that I have to wake up.
Yeah, I understood your point. What I think in that particular aspect is you are expecting the complexity.
yeah. But maintainability, it's not about maintaining the software later. This is about code maintainability.
No, so my point is
you
that
can,
if you don't go for perfection, you might stomp on the innovations. For
actually
example, if I
it's
stick
the
to
other
my
way around.
guidelines
It's
and-
the other way around. If you try to make, if you let's say maintainability is maintainability of code, right? So
Yeah.
I can create so many interfaces and make everything isolated.
Separate.
So I have an excellent maintainable software, right? It's a piece of art. However, because I made so many isolations, it's also now more complex for someone to understand. Okay? So that's where you have to make a trade-off that whatever code I'm writing, is it good enough for the next guy to understand and maintain easily? That is that maintainable. It's not about
Yes.
bugs, of course. Okay, so you should.
Yes.
We are not saying you should leave bugs in software. That is totally out of question.
Don't over-engineer.
So
Yes.
don't over-engineer. Exactly. So just
In terms of legacy systems or in terms of open systems, it's open. Using the open systems, like you get more number of support for securing the applications. Like
You mean you have an old legacy application and you're getting
yeah,
new
legacy is paid version is closed and it's within that closed you have to do an application you're going to give it to the customer or you're architecting it. But instead of the open system, then how you as an architect, how you are going to do that if you are using it? Because currently like OpenStack, HP, IBM, they are building their own using HP using so something they are going on with that and building on that. Like Docker for instance, Linux containers. Like in those terms, how as an architect you going to support or build and plan accordingly to secure your application to the customer? The customer needs this.
I mean, is it more about the security of the application?
So not only security, performance or whatever you are saying, maintainability, functionality, systems, everything.
I think it's very
But that's the
Security and performance are the reciprocal.
You get everything listed down actually as a requirement. If it's not there in the requirement, don't even care about it in the first place. It's always, this is a trade-off, right? As an architect, we always go overboard, right? Maybe 5 years before, I used to do the same thing. Now I understood that first thing is your delivery. Once you met the requirement, then you go and renegotiate. Okay, are these things? So let's say performance. Do you need 3-second page load, or are you okay with 4 seconds the first release? Do you need 2K key lengths, or are you okay with 1K? I mean, these things you have to go and talk to them.
These are key.
Exactly. I mean, it's all about how do you negotiate with the customer or your whoever is giving the to decide.
And you will revisit them. It's not that you're going to leave it at that. You might revisit in the future, but at that particular point of time, you think that you need a perfect solution or a good one. That's what I'm saying.
That's very subjective actually. Perfection is subjective in this case.
Yes.
So perfection can be.
Of course.
Can be.
Yes.
If you meet all the requirements, you are perfect.
It is okay. Yeah. What I'm saying, it's not about the requirements I'm talking about. When I'm doing, of course.
the functionality
Engineering point of view.
Yes,
Yes, exactly.
At the same time, I would say that there is a thin line between over-engineering and perfection.
Absolutely.
You need to
Yes.
understand which one you have to do.
Yes. And I understand your the whole build line what you're talking about was like you have to have the system in order to reduce the number of tickets.
Right. Kind of, you come up. So basically, what you're saying is you have to enable innovation, but then make sure that you're still sticking to a basic core design.
Yes,
not
right.
complex.
Yes, right. But the context, as he said, is more of the engineering what you're talking about. The code quality and the code maintainability and the performance. It's more on those terms.
In terms of innovation, like if you are innovating something and after releasing a product to the customer, if you wanted to leave it as it will be the cost burden to the company, right? When you are working.
I understand that, but see, at the same time, I think I'm getting this point because I've seen new design patterns into the code bases, which kind of freaked out pretty much everybody, and they were not comfortable with that. And then later we had to revert to something else, and that's, I think, where the architect is. See, we are all engineers at our core, and we try to solve very complex problems. We try to use everything new.
Yes.
But there are a lot of
Yes.
Yeah, but that's a thin line between innovation. If you want to push the boundaries, you might have to allow some creativity.
And maybe the innovation is there. You write a simple application for a complex problem. That's the innovation.
Yes, that is the innovation. Yeah. I would have put even a couple of more steps here, but it will take a lot of time. Yeah.
I just want to add one thing to what he said, that when you're using open source technology or even any technology that you haven't written yourself, you as an architecture really have to isolate your system from those. Today it is OpenStack, tomorrow it could be CloudStack and something else. So it's a good point that you brought up. So you have to create interfaces, you have to create some isolation in your software that doesn't care whether it's CloudStack or it is going to be something else tomorrow. So that's something extra you guys have to do as architects to make sure when you're depending on someone else's technology, just try to isolate your software from that. So tomorrow you can change it easily.
Yeah.
This movement is more so called just enough architecture these days. It's called just enough architecture, and that's catching up. It's like bringing agile architecture into the fore.
Yes.
Don't develop, Rome was not built in a day, so don't aim for the moon. Keep adding value in increments.
I do have a point for that next. I'll just move on. I'll move on to that. Okay. So the most important thing, the trade-offs. Okay. So it is virtually impossible to design an architecture that meets all the expectations. again, what do you mean by all the expectations? Like, I want everything which is high availability, high reliability, high security, high that, high this, high everything. So, yes, it is possible. We are not saying it is totally not possible, but it's like, why do you need that? Like, totally try to understand. So, it is virtually impossible to design that kind of architecture. Just don't go for that, where everything is required at high.
Yeah, it also cannot be done. For example, if I want high security, then I have to add a lot of levels. So that there is security at each level, but that also means performance will be affected.
Yes.
Because now the request has to go through several levels of check. So that's why trade-off. That when you want to gain something, you will also have to probably lose something. So
yeah, exactly the same point. Like when you want to achieve something, obviously you will have to lose out a little bit on something else. So when the expectation is like, I want everything high, it is like, no, you got to lose out on something else. So that is the trade-off. That is the trade-off. So again, one more impact of that is like fulfilling every requirement leads to unstable architecture. Sometimes it's a trade-off, sometimes it is like your architecture itself might become unstable. It might become a little weak. So you've got to understand which one you got to really need to have in your system, which one you can choose to have it a little less. Then make the decision. And then do not allow your architecture to go weak. Have it like you have everything, but yeah, at the levels what is required and what the customer asks for and what is good for the product. Hence, there are a couple of methods. Yeah, ATAM, architecture trade-off analysis method, CBAM, cost benefit analysis methods. These are a couple of methods which are used by architects in conjunction with the customers. So they can use these methods to do the trade-offs. They'll compare the requirements, they'll compare the performance, the security and those stuff, and then they'll come to a conclusion, fine, let's keep this, let's go a little low on this, so it's fine. Now the product looks good. So next is communicate the impact. If the customer is asking for all this stuff, you got to just be courageous and tell that it will have an impact on this. There will be a trade-off on this. Communicate the impact. That is most important. Customer has to know because he will be giving the product to his end users to use it. That is most important. And the last one is document. Why we need to document these trade-offs? I need answers. Anyone knows why we need to document the trade-offs that we do in the architecture?
You can look like a retrospect meeting.
Retrospect meeting? We are talking about agile and Scrum.
yeah, it is for you and it is also for your team. See, sometimes new person joins your team and immediately everyone will have suggestions, and suggestions are always welcome. Sometimes they will say, okay, why didn't we do it this way? Yes. For example, security. There are so many ways you can do security. You can add attributes, you can add request filters and so on. But you would have chosen one particular way, and if you document it here, you can always refer back to it and say, okay, this is why we chose this approach and not the other one. Okay, if you do not have a good reason, you cannot convince the new guy and he will somehow try to sneak in his new ideas into the system, and now you have two ways of doing security. So that is why for all the architecture decisions, you should have a clear reasoning documented somewhere so that you can refer back to it, and you can also explain to new people why you made that decision.
Building on top of that point, I think one more thing is that after 6 months, you might just look at the system and say,
exactly.
What has happened?
So that new guy can review yourself
your point
after 6 months.
But I've seen that happen. Yeah, that you stare at our phone board.
You yourself looking at your board and think,
for example,
let's do it differently.
Why did I do this?
So you have a framework you are trying to use, but then suddenly you went bare bones.
Yes.
You can't remember why did you go bare bones, because the abstracted layer that you were trying to use didn't have that feature.
Yes. Even I have experienced this and I have faced these scenarios when, as Anand said, somebody new joins and, oh shit, why is this being used? There are so many new things available now. But at that particular point of time, he's thinking about all the new features. He's a new developer. But architect would have made a right decision for the product. But for the new developer, and he is in the urge of learning new things, he might think that it is actually a wrong decision. But he has to consult the architect, or it is the architect's responsibility to talk to the developer and make sure that why the decision is taken, or ask him to refer to the document. He should be able to make sure that the developer understands why. It is equally responsible that developer understands, because tomorrow he should not become an architect and who don't document it, and again it becomes a chaos.
I like that here it
Are
also.
you saying like every time the decision is made are perfect at that point of time, and when developer comes will see, even though like this is perfect,
Yeah.
there might be decisions those are not perfect at that time also, and that developer will come and they can ask.
Yeah, of course they can ask,
solution you provide?
but you just need to know why you made a decision.
Yes.
You know, otherwise you will.
Who to reach out to, why.
That is different hierarchy. Every organization has its own structure.
The point here is that you need to document that.
Yeah.
So that
Document
Yes.
architecture is mainly for like why I have taken this decision.
Yes, exactly.
So even if you are not there,
So how many times you follow document? You all are architects. Tell me how many everybody is here. How many times you follow?
No, when you look at the code, or when you look at the architecture, when you think that it is okay, it is not like what I expected it to be, then you might have to go back and look at the document that why this is the case.
okay, you could of course also document in code.
I just want to answer to him. It is the perception. Whenever we think of a document, we think it's an IBM manual which used to.
Absolutely, that's what I was saying.
Yes. But here the documentation maybe just 2 lines or
Yes.
then the
Yes.
itself.
So that's
Exactly.
enterprise architecture document also, right? If somebody will come, it will show them business.
Yeah, it will be 6 lines of, because of these reasons the following architecture was developed. Maybe,
Yes.
4 lines of.
It really don't take much time, and all that matters in the document is that what is done and why it is done.
A simple thing could be that whenever you have architecture material, send it to me. That's it.
That is also good.
I mean, if there's
But it's better to have it in one common place, which is, everybody can see it. Of course.
I have a practical question. So how do you maintain this document? So because when ours runs into pages or multiple pages.
What document you are talking?
When talking about
The same document.
any decision we make, for example, we are moving from one server to another server or different architecture altogether. So, and how do you document it?
In our case, everything will have a life cycle, right? So you had a migration life cycle or a new life cycle where you added a new feature.
Because see, the thing is actually it runs into multiple pages. The newcomer finds it very hard to actually find where it is. Then only you can understand what it is.
Version will be there, right? Version control.
Version control is there, yeah.
Nowadays, DevOps team will be there. They'll be maintaining all each documentation, and they'll give you a code.
When code is, you can understand. But what if it's architecture?
Document also they don't maintain. They will it's hard to DevOps team.
Word itself does it. Word itself you can have.
But that's what we have, we use online document. But the problem is to find that it's.
No, so that basically means that your process is a little off. What you need to do is every newcomer needs to go to the reach, try to understand what has happened, and then pick up the code. If you're allowing a developer to come in and code directly, that's already not good.
We'll do one thing. We will discuss in the open sessions. The open sessions we have. Sorry. Shall we discuss this as one of the topics in our open sessions? Because we have open session slot where we can discuss actually the stuff like this.
Yes.
So we'll take that up in the open session. We are running out of time, so I'll just go to the last one I have. Yes, the most important what I feel out of all the points what I made. The great software is not built, it is grown. I see already nodding faces. Yes, it is true. Software architecture is not about big design. Like when I get a requirement, suppose if it's a large system to be built, I suppose if I'm an architect, then I would not be doing it at a big bang. Like taking months together to design it and then to figure out that okay, somewhere down the line after 6 months or 8 months, half of the stuff what I made is of no use. So what ideal case is like you start off with the basic things which is required for the first couple of weeks or whatever, the basic requirements, do that first and then build on it. What is the bad thing that can happen if you do that? Designing large projects upfront means more likely to be fragile, more likely to be expensive, more likely to be fail. The third part is the most riskiest because the whole product might fail. So you got to be thinking. First, don't go for the upfront design. I was a junior developer once. Of course, everybody was. When I was a junior developer, there was a project which came, and I got an opportunity to be a part of kind of a design what the architects were doing. It was a little complex application. They took months together to design it. But later, when I figured out, after a couple of months, half, 70% of what they designed was like absolutely nothing. It was not required at all. Because the requirements evolved, and then the code, everything got changed. Finally, the product was totally looking like something else altogether what the customer wanted. Sure.
Does this apply to projects following waterfall model as well?
I would say mainly it will apply to the waterfall model, of course, because right now we have Agile, Scrum and all these practices. Right now, whoever is following that, mainly they can fix these things as early as possible, because they know that, okay, we are not going the right direction, change it, and they can make it a better design as soon as possible. Yes, waterfall model approach is prone to these kind of things. Okay, so there is a term called walking skeleton. What is this walking skeleton? It's a tiny implementation of the system that performs a small end-to-end function. Though you have a really large system to build, first look at this walking skeleton. What are the basic necessities? What are the riskiest things that I have to take care of? Just combine the components, whatever is required, make sure these things work. The smallest part, just make sure that these things work. Then add muscles to it. Put flesh, then make it look like a human. So the walking skeleton is that. So make the simplest thing working. It should be like production, like code, and even the architecture. Make sure that works, and then add flesh, everything to it to make it more like human. So that's what is walking skeleton. So that's why we say the great software is not built. You are not directly building the whole system at first. So it has to be grown. You have to make necessary changes in between. You have to take decisions in between. You got to make that change. Don't do it upfront. That's what it is. And what is the takeaway? Have a grand vision. You should have a grand vision, what your product should look like. But you should not have a grand design at the start. Don't go for a grand design. But you should have a grand vision. You should have a good vision for your product. Yeah? Okay. To summarize on all these points, just first thing, focus on the needs of the customer who is actually going to use this. Understand and talk the business knowledge. Third, aim for the good enough solution over perfect solution. Fourth, the architectural trade-offs. You can't have it all. Just think and make the right trade-offs whenever needed. And choose incremental design over upfront design. Right? Okay. This is the references. Most of the stuff is there in the book called 97 Things Every Architect Should Know. I know that most of the people would have seen it, read it, but still it actually makes sense to go over it again and again. Just take a look what actually it says. Am I doing the things right? It makes a lot of difference. It's just reading and actually implementing it. Keeping the things very simple for an architect is very difficult job. We always tend to think to give a complex solution. No, the most difficult thing for an architect to do is keeping things simple. That is what is the vision of the architect should be, and that is what he should do. That ends my presentation.